Hello, I'm Clay Morrison, and this is my Lab 2 lab report. So, like Lab 1, the purpose of this lab is to calculate the amount of excess charge on a piece of charged tape. However, unlike Lab 1, the charge on the tape in this lab is treated as if it's distributed evenly across the tape rather than like a point charge as it was in Lab 1. So the physical principles used in this lab are Newton's second law, which of course relates net force to acceleration, Newton's third law, which states for every action there's an equal and opposite reaction, which was used for the uh, the reaction of the electrostatic force pointing upwards in response to the gravitational force pointing downwards, and Coulomb's law, which states that like charges repel and opposite charges attract, and the equations from Coulomb's law were used in the calculations for this lab. So the measurements are pretty much the same as lab 1. The length of the tape was 0.230 meters, and using the 1 gram to meter mass conversion, the mass that I calculated was 2.3 times 10 to the negative 4 kilograms. And the distance between the bottom tape and the upper tape at which I noticed some repulsion was 0.004 meters. So before I get into the calculations here, some of the assumptions that I had to make while doing these calculations was that I ignored air resistance on a moving object. So when I was taking into account the gravitational force on the bottom tape, I ignored any air resistance there that could lower that value. And I assumed that each U-tape I made had about the same amount of charge that was distributed evenly along the length of the tape. So even though I didn't assume that it was a point charge in this lab, and it is distributed along the length of the tape. It's in reality, it's not distributed evenly, but that was an assumption I had to make. So getting into my coding here, I started off, of course, with the my measurements and the constants up here, and then so this was the Q value here was the goal to calculate in this lab. I'll get into how I got that later, but it was basically through guessing and checking. And down here was the function for the electric field. It was basically the same as lab 0 and lab 1. And here is the given function that creates a line of charge. And this was basically initializing the top tape and the bottom tape and setting it up for the figure. And so in this block of code up here, this was used to calculate the electric force right here, and then down here gets into calculating the electric field and putting it up on the figure. And then so finally, right here, this line of code creates the electric force vector, which will be in white, and then the gravitational force vector, which is equal and opposite, pointing downwards in yellow. And then these print the statements. So as you can see here, this is the green arrow is electric field, red's top tape, yellow's blue's bottom tape. The yellow represents the gravitational force, and the white arrow represents the electrostatic force, as you can see, pointing upwards and opposite from the gravitational force. And then so basically to get the magnitude of the electric force equal to the gravitational force, I had to guess the Q value, which I mentioned earlier. So back here, I basically had to guess and check until I got those values to be roughly equal. And then the value that I found for the net charge on one tape is 3.64 times e to the negative 8 coulombs. And yeah, the values are roughly equal, so that's as close as I was going to get. So getting into the questions here, if I had modeled each of my tapes as a single point charge like in Lab 1, the value would have been a lot smaller. So my value from the previous lab was 2.03 times e to the negative 9, which isn't to the power of the negative 8 like it was in this lab. So these values differ because, like I mentioned earlier, the charge in this lab was treated as if it was distributed across the length of the tape, while last lab was a point charge. And this lab, the value from this lab should be more accurate, since in reality, the charge is distributed along the length of the tape and isn't actually a point charge. So that concludes my presentation. Thank you for listening.